could not participate. So we'll get that started. But we are very excited. If you have not done so already, we encourage you to get your audio connected following the information that's set out on the screen there. At the top of your browser, you should see an option for a telephone, a drop-down menu. If you click that option, you can use the dial out menu to enter a phone number for it to reach out to you directly, so that when the time comes to ask, when we have some Q&A, you can feel free to be connected orally and verbally ask your question. In the meantime, while you are listening in, we do ask for you to keep yourself muted so that we can cut back on any background noise and things of that nature. I'm really excited tonight to have Dr. Shuchi Grover, who is going to be here with us. She is a senior research scientist with Looking Glass Ventures and a visiting scholar at Stanford University. And I have known her for many, many years as someone who is truly dedicated to CS education and helping educators figure out ways to better know and understand what their students can learn and do. And so I'm just delighted that she was willing to share some of the wonderful research that she's been doing, and I think you all will learn a great deal from it. I will be here in the background on the webinar, so if there's any issues or concerns you have in terms of technology, feel free to shoot me a note, and I'll try to help troubleshoot that for you. But in the meantime, I will go ahead and turn things over to Shuchi. And remember, Shuchi, use those arrows in the bottom left-hand corner to forward your slides. So I'll let you take things from here. Thank you.
All right. Thank you, Melissa. Can you all hear me, Melissa? All good?
Yes, you sound great.
Okay. All right. So welcome, everybody, and thank you for that introduction, Melissa, and thank you for this opportunity to share this work with the broader community through the CS for All forum. I'm delighted to be here, and I'm delighted to see many of you joining in during the summer on what is a break for you all. And as some of you know, I'm a researcher focusing on research in K-12 CS education and computational thinking and aspects of curriculum and pedagogy and assessment, as Melissa said, and I am very grateful for this opportunity. So the work that I'm going to present, none of us works alone. We all benefit from our partnerships and collaborations, and it was done with former colleagues at SRI, current colleagues at Looking Glass Ventures, and most importantly, collaborators in schools in San Francisco and New York City, where we piloted the assessments and conducted classroom research using the instrument, and several individuals who have been named in there. And a quick sense for the roadmap. I'll speak briefly about assessment in general in the beginning, because I do believe our framing of assessment is important, how we think about why we assess, what we hope to achieve out of it. And summative assessment specifically in this conversation, I guess I should clarify that we could be formatively and should be formatively assessing too, but that is the topic of another conversation another day, I guess. So first we'll talk a little bit about why we assess, why we should assess summatively. And we all know that, okay, here we go. So we all know that formative assessment, of course, is integral to classroom learning, but summative assessment serves to help us understand student learning. It helps us with curriculum and pedagogy and evaluation of our own teaching and our own curriculum and what it is that we are hoping to achieve with learners, with teacher preparation and district planning and all the aspects that are crucial to bringing computing into the classroom. And so an assessment such as the one that I'll be describing helps provide us the evidence that we need to draw good inferences about what students understand and know and are able to do at the end of a term after studying introductory programming, and in our context, it's in around middle school years. And I should reiterate here that our goals for CS in K-12 go beyond just understanding of concepts and skills. We all have internalized that. We all understand that. We do care about broadening participation. We care about promoting equity and engagement and interest. We want to shape and help shape learner identities. And so naturally, we need multifaceted and multi-pronged assessment strategies, and that's been the subject of other work and articles that I've written. And so CS for All, rightly, we don't want to move into standardized testing and accountability. And, there needs to be accountability, of course, but we don't need to be teaching to tests. But the bottom line is that we cannot improve if we don't measure. And so new curricula and new frameworks and standards are being written, teachers are being newly trained to teach, and so there is a need for feedback. We want to promote learner understanding, and rigor is part of equity too. And we need to understand and address student misconceptions. We need to refine curriculum and pedagogy accordingly if there are gaps that we encounter. And so for all of that, we need to measure students on some kind of objective outcomes. And so measurement, and I often use the word measurement rather than assessment simply because assessment sometimes has all this baggage associated with it. So measurement provides us feedback on coverage, how well students are learning, and that feedback is so valuable to teachers and to districts and curriculum designers and to us as researchers when we are involved in these efforts. And of course, funders who are funding teacher PD, for example, or curriculum design. And we all want to be able to be meeting those outcomes of student learning. And so, while we recognize all of this, this assessment specifically is, going to be focused on conceptual learning, and I'll go into that. And I won't go into this too deeply, but we do have challenges that are unique to computer science. It is a new domain. We are in uncharted territory. We don't have a whole, body of literature to understand how students are learning, how we bring in social and cultural aspects into the classroom, and all of that. But there are, efforts to sort of define some of these things. The standards that people are, so many folks in various states are writing. The CSTA came out with standards, so that's helping to some extent. Developing good forms of assessment is itself a challenge too, and because we want to elicit valid evidence. And the reason assessment is a challenge in computing especially is because of the idea that we have programming environments and students could be assessed through programming, should they be assessed outside of programming, and all those things. So, these are the challenges that we try to address, and it is important to point out and share that these are things we do grapple with. So this assessment was focused on introductory programming concepts, and the reason we focused on conceptual learning was because of this recognition based on decades of research that students struggle on three aspects of computing when they learn introductory programming. It's syntax. They learn the syntax of a new programming language or environment. They have to learn the conceptual aspects of that programming language and environment, and they have to study and understand practices of programming. And all of this together causes a huge cognitive load. Everybody knows that. I'm speaking to teachers who have been experiencing a lot of these things in the classroom. Aspects of syntax are sort of addressed by the new block-based programming environments folks are using. They're engaging. They help with syntactical issues. But gaps in conceptual learning still tend to persist amongst novice learners. And even though programming projects present a much more authentic form of assessment, they are very time-consuming to score, and they're hard to score objectively. There is a lot of subjectivity that goes into it. They're not always an accurate indicator because students often, sometimes get their code going with trial and error. Sometimes they reuse pieces of code and such. And so, but that is not to say that those shouldn't be one form of assessment. And in fact, going back to this point, that an assessment such as the one that I described is just one of the various forms of assessment. A programming project brings in many other elements of collaboration, of learner interest, because often students' projects are drawn based on their backgrounds and their interests and the things that they would like to sort of express themselves through. And so this form of assessment should be considered as one of many. So when we operationalized the domain of middle school introductory programming, we looked at a bunch of literature and documents and things that are sort of emerging in the field, things like the K-12 National Framework, the CSTA standards that were emerging at the time when we were designing this assessment. We started about 2 years ago. Background research on learner difficulties in K-12. We even looked at ECS and APCS principles projects and not projects, curricula and assessment, because middle school is sort of a pathway to that as the next stage. And so, we kept that in the frame. We consulted experts in the field, and I should add that my own prior research before I led this initiative also looked at middle school programming and looked at learning goals and assessment design. So that also fed into this. And the concepts that we came out with were that we would look at conditionals, variables, loops, booleans, abstraction, and expressions. And hopefully you see your own curricula and goals and other things sort of reflected in this flower here. We had a good, template to work with, fortunately. So I had been involved in this big project that SRI International had led to design assessments of high school, of the high school exploring computer science curriculum. And so we had a process template for how to design the assessment, but there was one key distinction. This assessment, which I will call the MSCS assessment or the VELA, because it came out of this project that we call the VELA project, was not aligned to any specific curriculum. We tried to develop an assessment that could be used broadly for middle school introductory programming. And what we used was a principled approach to assessment design. It's called evidence-centered design. And it injects structure and integrity into the process, or what we would call in assessment terms validity. And it's a multi-step process. And if we had the luxury of time, I would go into details of process. And I think there are some writings that are coming out of this work that will go into process. But for now, I'm going to leave it at this to say that this is, and it's not as linear a process as it looks. It is an iterative process of design and refinement, an iterative cycle throughout. And even though we didn't have a specific curriculum to align to, we did start with a set of learning goals. And I hope everybody can see this. I know it's hard to read, and I don't expect everybody to read this right this instant. But suffice to say that all of these sort of touched upon those concepts that you saw in a couple of slides ago. So it talked about the various aspects of introductory programming that we hope for learners to learn. And if you're eyeballing this, you're seeing variables and loops and conditionals and repetition and data types and operators and even elements of structuring a program into structural subcomponents and such. These learning goals were used to arrive at a set of FKSAs, and that word, their attributes, actually stands for is abilities. In our last-minute rush, we weren't able to load the most final set of slides where I'd corrected some of these typos. But while learning goals are curriculum-facing, FKSAs are assessment-facing. And so, they outline what we expect a learner to be able to do. So, for example, the ability to identify a repeating pattern, the ability to describe how a conditional pathway would operate, the ability to create variables, assign values, the ability to evaluate a Boolean expression, the ability to identify subparts of a computational solution, to identify, to create an expression using existing variables, etc. And so I've just spoken just read out a few, but that is what we came out with as our set of FKSs that we would define the assessment we would align our assessment items to. So what we have as an assessment as it stands today went through various cycles of piloting and iterative revisioning over a period of about 2 years, which included sharing the initial FKSs with experts in the field who were our advisors on this project, early designs, piloting it in classrooms through 2 rounds of piloting with about 200 students, 100 students each time. We got teacher feedback. We had one-on-one think-alouds with students. We had some teacher feedback suggested that the language was too complex. Often children are unable, even in middle school, they may be at 4th grade or so reading level. They're ELL students, and so we had it reviewed by an assessment expert. And what we came out at the other end and what we have today is a paper and pencil assessment. It can be administered on paper, but it also has a computer-based version now that is on an NSF-supported assessment platform called Infinity. And the assessment is expected to be completed in a 45 to 50-minute period. We have scoring rubrics, etc. And I should add, having just spoken about the ELL expert review, that it is targeted at about a 4th grade reading level, even though it is meant for middle school students. So just a quick snapshot of the kind of teacher feedback. When we were piloting, we were just giving it to teachers who were teaching whatever they were teaching at middle school CS. So often when we piloted, we asked teachers. I'm hearing an echo suddenly, Melissa. Is that an issue? Okay, it's gone now. So
I think it might. Hi, Shuchi. I think it might have been someone speaking, but I think that it looks like they've muted themselves now.
Okay. All right. Not a problem. So we would get a sense from from the teachers whether they thought that the students would be able to answer this, how many might be able to answer, and we also got a sense for whether they were actually covering that topic, because it's not fair to sort of look at student performance on an assessment for our assessment design purposes, and if a teacher says that it wasn't covered, then we know how to sort of view the responses that we were reading. But what we found often, and I should add this, is when we were piloting, often teachers, it ended up being that teachers realized that they were not covering certain topics well enough, and they did say that in this feedback. But a lot of them, like I said, talked about the language used and to make it simpler and things like that. So, this is just sort of an item map. It doesn't mean very much at this time, and I'm going to go into items really quickly. But the idea was that we came up with about 9 big questions, and they had subparts. And the subparts were aligned to various FKSAs, or rather the entire item was aligned to various FKSAs. And you'll find that some items, for example, 4, 7, 8, they align to many FKSAs, and that's because they had several subparts. And they were also the kinds that would probably be much better now speaking of the difference between formative and summative. In formative, you sort of align your items to specific topics that you're teaching in the classroom so that you get idea on specific misconceptions or their understanding of what you've just taught them. But in summative assessments, like with a final project, for example, you're sort of bringing everything together. So there are items that sort of look at a whole program that sort of speak to an entire program rather than, or not just an entire program, but speak to many topics as part that are part of our FKSAs. So they speak to variables and loops and expressions and abstracts. That pretty much covers the gamut of the kinds of things that we are trying to cover. So there are some items that did that, and some were much more specific. For example, 5 and 6 were only about Boolean expressions. Number 1 was only about a conditional really, an evaluation of a Boolean expression. Number 9 was just about loops, understanding of fixed loop. And I should add, I forgot to mention this, that it was designed with Scratch in mind. But of course, we can design versions of such a curriculum with other programming languages in mind. The idea is that all this process and thinking has gone into this. So clearly, designing an isomorphic item before, say, SNAP or ALICE or something else might not be such a stretch. What else do I want to say here? I think, again, total points added up to 60. I should say that after our piloting as a pre-post measure as part of our classroom research that I'm going to share, we did decide to change item 2 because it performed badly. It was still ambiguous in its wording. It was just something we'd been tweaking, and I recently piloted that item separately with the help of some teachers in the community. So let's see. Okay. So in the end, this was the kind of, okay, so I guess I cannot, oh, I can. So this was sort of just a brief look at the way the assessment looked, for a learner who was trying to attempt it. And I am going to go through those 3 items especially that I pointed out, and there is another reason for doing that, and that is that those items ended up being the most, and in assessment jargon, assessment science jargon, there is something called a discrimination index, and they had higher discrimination index in that they were able to discriminate better between learners who understood things well and those who didn't. So here is item number 7, and I don't know how much time we have already covered. Is there a clock somewhere? Anyway, so you're programming a maze game. The screen shows a cat, maze walls, and gold coins. You make the cat move around the screen to find the gold coins. The maze walls and coins stay in the same location every time you play the game. You start with a score of 0. You have 5 lives at the start. If the cat touches a gold coin, you gain a life and your score increases by 100. If the cat touches a wall, you lose a life and your score decreases by 100. The game ends when you reach a score of 500 or have no lives left. If your score is 500 when the game ends, you win. If the score is less than 100 or 500, when the game ends, you lose. So you can see this is a very typical scenario of a game design that a middle schooler might attempt. And so we wanted to sort of present a problem that we would see how a student would conceptualize even though they're not in a programming environment. So the first part, and you can see that it touches upon several FTSs, but variables and expressions and well, let's see, what else? Evaluating expressions, understanding how variables change, how to initialize, etc. Anyway, so the first one was to see how they can conceptualize the idea of variables. So what is changing and what is not changing in the game. Then we asked them to describe one variable that they feel is needed to program in the game. What would they name the variable? Because we feel that, does the learner think about variables as having meaningful names? That's the kind of thing we try to encourage. Describe the purpose of the variable. What is the starting value of the variable? Then, what happens when the cat touches a gold coin? Use the if block below and write your expressions one below the other. Use variables score and lives in the game. Score is a score, and clearly we are trying to now scaffold to some extent, because if learners have understood the problem, they don't need these hints, but we feel that we need to be able to evaluate how they write an expression. So at that point, we've already sort of assessed whether they understand the idea of variables, and so we give them the knowledge that they need to be able to attempt this without stressing them too much. And so we expect them to write the 2 expressions for the changing of the score and lives. And there's a similar question, the next question, which is what happens when they run into a wall. So these are the 2 if statements that are there presented as if statements in the question prompt. Then we ask them how to decide when the game should end. And for that, they have to write an expression, and they have to use the variables, and they have to use the repeat until block. And in the end, they need to basically come up with an if statement to decide whether you have won or lost, because the repeat until sort of takes you out of the loop when the score reaches 500 or lives is down to 0. But in order to determine whether they've won or lost at the end, they have to check the score, which is clearly defined in the question prompt. This is number 7. And number 4, sorry to have gone back and forth like this. This one is touches upon seeing if students sort of think about problem decomposition. Do they think about the structural subcomponents of the program? Are they able to see how variables should be updated and how expressions should be created and evaluated? And we present it in a slightly different way. Here we present it as multiple choice items. So we have Kayla here who is saving money. I'm sorry I can't read too well because this is only one small part of my screen. Anyway, Kayla is saving money to buy a new bicycle. She has 6 uncles. On Kayla's birthday, each uncle gives her money to buy the bicycle. Figure out if she has enough money to buy the bicycle. Kayla creates the following program. And so we have the program all written, but we have certain gaps in the program. And so even before we get into having the students identify what those gaps would be, we have them, we want to sort of promote them to conceptualize the program and the subparts of the program, to basically see, do they even understand what's happening in this program? And so we give them 3, what part of the program is summing up, what part of the program comprises the amount of the price of the bicycle, and what part tells Kayla whether, I can't read too well, what part compares the amount of the bicycle, tells Kayla. Melissa, is there a way for me to increase the screen size of what I am, the slides, because I'm seeing a very, very small version of it. That's only part of the screen, and I'm having trouble reading.
We can't, unfortunately, we can't do that universally. You would be able to make it larger on your own screen, or select.
And I guess I will lose all the chat stuff, but I can do that for now, right?
Say that one more time.
Yeah, I've made it bigger. Thank you. So, okay, so to figure out, so now I can read it all much better. Compares the amount of the price of the bicycle, tells Kayla, and we've marked these 3 portions A, B, C, and we expect the students to sort of answer that. D, E, and F are really about seeing if they are able to see the initialization, where they have to initialize the, total money received variable, whether they understand that the total money received has to sort of be this aggregator variable that's, that keeps getting incremented by the amount of the gift that each uncle has given, and this happens in a loop that repeats 6 times. And in the end, there's this Boolean expression where they have to decide whether, is the bicycle price less than or equal to the amount that I have received, and that's the Boolean expression they need to choose. Now, this was a problem that was adapted from the Israel national exam in 2012. It actually only had what you see as D, E, and F. So we added this first part of the problem decomposition, and then we added another part to it, which was, I'm sorry I don't have animation, so you're seeing everything all at the same time. So ignore the scoring for a moment. We added this part again because we feel students need to be able to understand how to convert, say, a fixed loop to, a repeat until loop, where a Boolean expression determines when to come out of the loop because you don't know how many times you're supposed to repeat. So here we said that Kayla has a friend, Simone. She wants to buy the same cycle. She doesn't have anybody to gift her that money. She decides to do this GoFundMe kind of campaign, and she wants to stop accepting donations when she hits the amount that she needs. And so write the expression and use those same variables, total money received and bicycle price. And this scoring rubric is just giving you a sense for the way we scored. Of course, the first parts were very easy to score, but for the last part, for example, any open-ended prompt we have to account for the small variations that students may write in. Sometimes they miss certain parts, sometimes they use words, sometimes they, so we try and give credit for as much as, however the student has sort of expressed their solution. Sometimes they miss some part of it, and so we give partial credit and things like that. So,
Shuchi,
yes.
Can I ask you to pause for 1 second? So we have a question in the chat box from Paige, and Paige asked, did any of the class activities have similar types of questions, or is this the first time the student was seeing a question of this type?
When you say this type, Paige, can I just ask, when you say something with like gaps, fill in the blank kind of thing? I'm going to assume, so here's the thing, since this is a broad assessment meant for broad use rather, I would say that yes, if a student has not encountered this kind of a problem, there may be a little bit of they may be a little uncomfortable coming into such a problem, which is why we added that first part where we're sort of trying to, in some ways, just explain to them the 3 parts, even though we are asking them to answer A, B, C, and I'll go back there, sorry. This is where we are trying to sort of connect to the kinds of things that they may have done in other pieces of code, which is, initializing a variable, going into a loop to sum up something, and then comparing, which of course points to an if then else. And so I do realize where your question is coming from, and one of the things that I feel these kinds of assessments, of course, sort of signal to the broader community is that there can be these kinds of assessments even used in formative settings. You could present students with a piece of code even in a formative classroom setting and sort of take out just the expression and say, what's the expression we're going to put in here, which expects them to sort of, code comprehension is one piece of it. They have to comprehend the code, and based on that, they have to sort of come up with what it is they need to there. And because this is sort of a newish type, which is, it's another reason why we don't give them these multiple choices. And the multiple choices are also a signal for the kind of thing that looks very familiar to them. They know that they set things in the beginning. They know that they change things in a loop. But, these are all signals, and we hope that students I hope that answers that. I'm not able to see chat, but I'm going to move ahead, and we can come back to this if I have not addressed the question. So the question
yes, Paige
8
said that you did answer it, and I had asked if there were other questions. So if you do have questions, then feel free to put it into the chat window, and I may pause you from time to time so she did address those before you get too far ahead. But please go forward now.
All right. Yep. So number 8 is about patterns and abstraction. And again, it's the kind of problem where we're almost walking a student through the conceptualization of the problem. Because, like I said, we are focusing on their conceptual learning. We're not expecting them to say, some problems, some items are very directly related to how a loop works or how, but some of these problems, and that's why I wanted to share them with you, get your reactions, get your feedback. So this one is also one of those. This one is about students recognizing a pattern and ultimately coming up with a general solution. So that's very broadly what we're trying to do here. So we have given them what students may have seen in maths class, in fact, as children, they may have seen these kind of patterns. And we first asked them to write step 4 of the pattern. Most students get that correct. Then we asked them to describe in words what it would look like for step 600. In fact, in one of our earlier pilots, we had said step N, and we found that N itself was a little disconcerting. And so what we did was just pick a very large number, the idea being that they cannot sort of draw that entire pattern like they could for step 4. They would have to describe it in words. Then we ask them to sort of go a step further and now automate this solution, right? And so if this step 600 were to be programmed to produce step 600, what is one of the scratch blocks you would need? And we have all of them, but clearly everybody knows that there is a repeating pattern here. And most students sort of get that part too. Then we ask them, we give them an idea of what pseudocode looks like to be able to describe this program. So we say, suppose this is the set of steps that draws the program. Draw a star, move to the right, draw a star, move to the right, draw a triangle, and draw a triangle. That's step 2. Now use this kind of knowledge to use step 600, but use the scratch block you picked in part C. So we are again scaffolding them through to the next step of actually conceptualizing the use of the loop construct and to come up with that. Then we actually expect them to now think in terms of a scratch program. And what would it mean now we've gone to step N, so to speak? So now we say that we don't know what it's going to be. So write a general program that expects as the input step number, the number of steps that you need, which step number you need to produce, and use the step number variable instead of a value of a particular step, as they have until now. And we give them the starter code to sort of concretize what we've described. And then we give them the first 2 steps, which are already been written as, in words. And we expect them, these are the kinds of things we need to do when we're sort of assessing through pen and paper and trying to get as close to programming as possible. And so we expect them to next have a repeat loop, which repeats, step number of times. And of course, there is a before loop aspect and a within loop aspect to this. And that's one of the things that is one of our learning goals, that when students think of loops, they think of what goes before, into, and after a loop. And so we feel this is an important learning, and so clearly we have the 2 stars that come before the loop, and then the triangles are drawn within the loop. And I don't have the scoring rubric shared here, but we did sort of accept a lot of different kinds of solutions for this. And we try to be we try to be as generous as we can when, we're just trying to see whether they get the broader picture here. But we do look out for certain things, and do they do the before loop? Do they do the within the loop stuff? And so that's one discrete learning. Do they repeat step number of times? That's one key part of it. And then does only the triangle part get repeated in the loop? But within the loop, the way they express the drawing of the triangles may be written in different ways, etc. They may not say move to the right. We decided not to sort of, they could have a function, for example, which just draws the triangle and moves to the right. So we sort of become lenient on those aspects of it. So I just want to give a quick sense for how this assessment fared. Of course, I couldn't go through all. I had all the snapshots, and Melissa told me, you're not going to be able to go through all of this in one hour webinar. And I will, I'll go into more details of how you can get the assessment and everything. But we did try it as a pre-post assessment after an intervention that we ourselves had designed. So we had an intervention which is part of the VELA project, where we actually went into classrooms and taught the students these topics. And test, retest, and sensitivity to a curricular intervention is one of the aspects of validity of an assessment. When you have taught these topics, do you see a movement in students' scores? And it has to be sensitive to instruction. And so it's called instructional sensitivity. And so we actually taught a curriculum in 3 middle grade classrooms. They were taught by teachers, actually. We trained the teachers on our curricular activities that touched upon all these learning goals. And I have to point out, grade 6 and grade 8 were in very low performing schools. You can tell by the school characteristics. They were just in very, very impoverished neighborhoods. They had very poor math, and many below proficiency, below grade level in math and English and science. Seventh grade, as you can tell, was at or above. I mean, it was what one would call in a higher performing neighborhood. And what we found was all students in all the classrooms did significantly better from pre-test to post-test. We had the highest performing was the seventh grade. The grade 8 was a very small grade as well, and there were other issues. The intervention timing was very different in that classroom. But anyway, we got some data on this that gave us a sense that it was harder for sixth graders. But again, the sixth grade classroom was a struggling classroom. So but this is what it is. We do have one does have a gamut of classrooms that one encounters, and so the average score on the assessment was about 70% across all the grades. Males and females did comparably. The score distributions were sort of skewed toward the right. These are just the kinds of analyses we do. There were correlations with math and English scores, which is sort of an indication that they correlated with math, with prior preparation. But learning gains for all three grades, it was independent of the grade. So all three grades, the learning gains from pre to post. But that spoke more to the intervention, I would say, than to the assessment. So as you can see, there were some questions that were much easier than others. In the question 1, 5, 6, students mostly scored very highly. And questions like 4, 7, and 8 that we just discussed were sort of in the 60, 70, 80 range. The scores often for 7th and 8th grade were very comparable, but the 6th grade were lowest. Question 2 performed the most, didn't fare well, and so I think I have a little bit on that. I'll come to it. And question 2 is the one that we decided to sort of redo. And, these are just things that we did as part of assessment design. You have to sort of do certain analyses, but there was high internal consistency amongst the items. The assessments reflected a high level of reliability. Item 2, like you saw. So these were the average scores, the middle column. I have sort of dimmed the others that speak to, reliability and discrimination, but difficulty is actually the average score. So the average score for 1, 4, and 5 were very, very high. Question 2 really did very, very. We don't expect students after, to score that low. So clearly there was an issue. But otherwise, these were assessments that you would expect, 70, 80% of students to be getting things right, and that is. Normally, when you give assessments, that is a normal expectation. We also did analysis based on the concepts, variables, loops, abstraction, Boolean expression and conditional, variables plus loops, variables, and arithmetic expressions. Those are those codes there in the lower graph. And we found that individual items that assess one single thing, of course, are easier. When things start to come together, variables and loops and a conditional, variables and loops and a Boolean expression, that is where students struggle more. And so if you want to focus your attention, if you have to take anything away from the learning, at least as evidenced by such an assessment, it feels like, it would be better if teachers and our own intervention too, whatever it was, should have focused on these combinations better. Interestingly, if you see question number 9, it had a very high discrimination index, which means that it could be high and low performers very. This is all the assessment is. This was question number 9. So simple. It just says, let's start, repeat 3 times, say hello, say goodbye, and in the end, say finished. So it had a before loop, it had a within loop section, and it had finished. And you had to write what the fox says. And actually, it didn't perform very poorly in the sense that, 71% of the students did well. But it is an indication of an assessment that is able to very quickly suggest to you those that are not understanding the concepts of loops. Some problems have this quality. Some questions have this quality where they're very, simple questions, but they are able to surface for you misconceptions very easily. And this is one of them. So I wanted to share this example. Question number 2 has been revised with the help of some of the folks in this community. They may or may not be on this call. I revised it with their help, and we ran it in a few classrooms recently as a separate item just to see if students were able to understand, etc. And I don't know how much time we have left, but I really want to go over it very quickly. It was an item where the FKSAs were touching upon the fact that variables can only hold one value at a time. And that was one of the things, and the fact that this was buggy code, so we expected students to see if they could pick up bugs. So this was the only, and that's why we couldn't throw this question out, because if we threw this question out, we wouldn't be covering those FKSAs. So we redesigned it, and so clearly both problems, part 2A and 2B, have bugs in them. The first one is only supposed to allow students between, friends between 13 and 18 years of age, but the question, the if statement only says less than or equal to 18. So, is that correct? Will it sort of let in the right kinds of, if this is the rule that Jenny wanted to follow for her party, is this the correct rule? And the second part was, in her party, she wants to greet people by name. She wants to ask them when they enter to enter P for pizza or B for burger, so that she can keep a count and place an order accordingly. And here the two asks are done one after the other, and then she wants to say hi to the person, and so obviously by then the variable has got overwritten, and so we ask the students, what will the program say? Will it say hi Jenny, or hi Amy, or whatever, and why does it do what it's supposed to do? And one of the interesting findings that I had was that many students don't understand the join operator. Now again, this is a specific context, but in this particular context, many students didn't understand how to say join, hi, and answer. They said it wouldn't say hi Jenny because I don't see hi Jenny written anywhere in the code. They don't see that that's a variable value. And many sixth graders did not understand the less than greater than, so maybe there's a mathematical, sophistication required here. So, I mean, one of the things about the assessment is that, it is what it is today, but and it will be published with all these caveats. That was one of the reasons to sort of share. But I do want to sort of understand from folks if this was a question where we shouldn't have part B, although that part B is the one that looks at variable value being overwritten, and is it too difficult for sixth graders? Maybe teachers can, decide not to look at that question for grade 6. I mean, teachers can use any of these assessments in any way they want, and if they do decide to give it to a sixth grade, they can choose to ignore certain, how students do on certain items and such. But interestingly, the CSTA standards I noticed for grade 6 to 8 mentions, and it actually mentions that understanding variable types and string types is one of the things, and it gives an example saying students could write a program that prompts the user for their name, stores the user's response in a variable, and uses the variable to greet the user by name. Now, we didn't use a variable for the name here, and that was one of the things, but it is basically that goal that we were trying to assess here. So really coming toward the end of this presentation, how might you use it? We are in the nascent stages of computing in K-12. Several factors contribute to student performance. So, the whole idea of an assessment is what you do with it. And don't try to sort of, you as a teacher know what factors go into teaching a curriculum. Schools know what factors go into teaching CS, and students' backgrounds, teachers' preparation, and district resources, so many issues, how much time they were able to give to topics. And so assessments need to be used with all those things in mind. And there are affective factors at play that we care about, interest, engagement, etc. So it's crucial that such a test should not be the only measure for grading a student at the end of the course, and that's something I want to make very clear out there. I mean, we make such an assessment. It can be used for research purposes by classroom teachers, but I would urge nobody to use an assessment like this as the sole grade giving component at the end. It should be one of many forms of assessment. As you can see, it clearly targets certain concepts, but those are not the only goals for a course. And so it does give you a sense for whether students are able to understand things or not, and that is how it should be sort of looked at, along with various other forms of assessment that provide a much more holistic measure of student learning and engagement. And this is something, it's a topic that's been close to my heart. I've been talking about systems of assessment for a long time. Now it came out of work that I'd done from 2013 to 2015, rather. The paper got published in 2017, but that's how research works. It's slow. My last point is going to be about whether folks are interested in using. I presented this assessment and paper at a conference earlier this year. I'm going to be uploading that paper because it has much more detail on the process and the refinements and all of those things. It's available for folks to use. But those who want to use an online version of it just for easy administration, create an account on edfinity.com and get in touch with me, or get in touch with me anywhere, and I can inform you how to do it. And it is still an early stage for understanding how this assessment is, how well it does, whether it's a good assessment or not. We feel it's been designed in a very robust way with good alignment between the goals that we had decided and what we produced at the end. And so if you decide that you can share, if you ever use the assessment and want to share how your students performed, it will just help us. And it should be in an anonymized form. I don't, need to get any other information other than maybe student grade, because that is useful to know how 6th versus 7th versus 8th grade students do. And that can inform future use and perhaps revision of the assessment.
Shuchi, we have a number.
Sure.
We have a number of questions that I want to make sure that we get to, because we're closing in on our hour here. So, yes, we have questions in the chat box that I want to just bring to your attention.
So how do I go back to the?
It's okay. Just listen up, and I'll share them with you. So first question is from Ian, and Ian asks, what methods are recommended for encouraging or training teachers on creating and scoring assessments such as this? We were most recently provided assessments by our district without dynamic questions such as these. There is need for improvement. He said that the questions typically look like x equals 0, x equals x plus 5, what is x? Useful in isolation, but not dynamic.
Okay, so I want to understand, I want to be sure that I understand the idea of dynamic better when you're saying, so a pen and paper assessment by its very, modality is we can't infuse dynamism into those questions, but as you can see, we did a lot of things in our assessment design that sort of speak to the idea of the flow of the conceptual sort of thinking process that we would like to sort of get evidence for. When you say dynamic, let's see, this asks the students to interact with the program that has a purpose rather than x equals. So when we design online assessments, one of the things for these very assessments can be much more dynamic when they are in an online mode. And as it happens, there is work afoot. It's work that I am involved in doing, is to make these type of assessments much more dynamic in terms of, putting jumbled blocks of code in correct sequence, drag drop, filling in values, various kinds of dynamism that comes from moving this to an online modality, even if it is not a programming assessment per se in a programming environment. And even, I mean, you could even embed small, in-browser microverse, I mean, with the online mode, it can become much more dynamic. I think I'm hoping that that's what Ian was speaking to. Of course, this is and speaking to helping teachers learn to design assessment. That is again something that some of us have been hoping to sort of infuse in PD. This idea of assessment literacy and being able to understand how to design assessment, how to use assessment, how to adapt, all of that. I think it is a literacy. It is part of teacher preparation, but given the way CS K-12 has sort of evolved and moved, I think the need of the hour in the beginning was just to get so many teachers that were just so unfamiliar with computing as a subject to just understand what it is they were to do in the classroom. Assessment is something that they, now you're hearing them. It sort of is, I think, the next stage in the evolution of professional development for CS is to sort of include these type of things. We will be working with constraints. All of us are, the whole field is working under some, constraints of teacher capacity, and so we're all working to build that, and one step at a time, I guess.
And it looks like there are several questions related to using this as a pretest at the beginning of a course, or whether that's a middle school course or the beginning of an Intro to CS course in high school. Your thoughts on that?
Absolutely. I think this is also that the diagnostic, sort of using an assessment as a diagnostic, I think is great, because several students, and that's, we ask the question often in our research, have you done any programming? And it's a yes/no question. There's no way we are able to really get a sense for students' prior experience with programming. And given that there's so much variation in this, even for learners that are learning programming for the first time as a formal subject, they may have done several other things outside. You want to get a sense for where your students are at. Sometimes students say, oh, I did 5 summer camps on Scratch, but they still may not know how to write a Boolean expression. It's just the nature of the beast, They do many things you don't know exactly. I think it's great to use as a pretest and get a sense for what your students, but you have to understand some students, some questions are just, commonsensical in some ways. So it may not, be indicative of it is indicative of something, and so definitely. Yeah, assessment 4
Absolutely.
as an yes, and ipsative assessment, assessment as learning, that's another form of assessment. No, those are extra slides. Never mind that. Thank you is the slide you can put up, Melissa. But if there are other questions,
no worries.
And yeah, those were a few extras that I sort of pushed to the end because there was way too much to cover. I hope this has been useful. I see Nicole. Hi, Nicole.
Well, just a couple of things that I want to share with folks before we do close out for this evening, and that is that we will be adding the recording as well as the slides to the event listing on the CS for All Teachers site. I just put that link into the window. We'll also be sharing it via Twitter as well. So if you want to have access to this information, you can go there in a day or two, and we'll have that updated for you. And if you aren't a member of CS for All Teachers, we give you instructions on how to get connected. I know many of you follow us on Twitter, but we'd love to have you as part of our larger community as well. And then just the last thing is I'm going to pop into the chat box here a survey link, which you'll also be redirected to that as we close things out. But we just love your feedback and would welcome you to let us know how you think things went tonight. I know there was tons of information. As I said, we'll be putting this up on our website for you to be able to access later as well. But we thank you, and thank you so much, Shuchi, for sharing so much of what you've learned and passing that on to this great group that was here with us tonight. Have a great evening.